Hi there, in this video we're going to learn about how to find angles when you have intersecting secant and tangent lines in circles. So what does this even mean? So in a circle we're going to look at the angle measures. There's two types. There can be an inside angle measure or an outside angle measure formed by a secant and a tangent line or a combination of the two in circles. So just as a reminder, a secant line is a line that goes through the circle, and it doesn't necessarily have to go through the center, okay? And a tangent line is a line that touches the circle at exactly one point on the outside of the circle. So this is going to be a tangent line, and this is the point of tangency where the line touches the circle. Okay, so case one. We're going to have the angle formed outside of the circle, and there's three ways that that can happen. So we'll talk about the formula in a second. So we can have two secant lines, 1, 2, okay? We can have a tangent line and a secant line, or we can have two tangent lines. The formula is the same for all three of these scenarios. You'll see that these lines, so either the secant or tangent lines, have now formed what we call intercepted arcs. So this right here is an arc that's formed by this angle. Okay, so here I have an intercepted arc, and here I have an intercepted arc. I have two intercepted arcs. I have one arc that's far out, the furthest away from my angle, and one arc that's closest to my angle. Okay, over here, this angle right here, formed by this tangent and this secant line, also makes two intercepted arcs. I have this far away angle. Now this is a point of tangency, so right here is where it ends. Here's my far away arc. Here's my close arc. And when you have two tangent lines, it's actually you're ending up using the whole circle, because this is the point of tangency here, and this is the point of tangency here. So your far away arc is from your point of tangency to the other point of tangency out here. And then your close arc is going to be this one that's closer to the angle. So the formula is always you take the far away arc minus the close arc and you multiply it by 1/2, and that's equal to the angle. So I have one example of each type, okay? So this first one, it says that the measure of angle AEB, which is this angle right here, is 48. So the measure of our angle is 48 degrees. It says the measure of arc CD, this one, this will be my close arc, is 36, and I have to find this arc right here, my far away one. So my formula is my angle equals 1/2 times my far away arc, which is x, minus my close arc, which is 36. Okay, when I solve this, I have two choices. I can either distribute this 1/2, or I can multiply both sides by 2 to get rid of the 1/2. I'm going to choose to multiply. First, I'm going to draw a line down the middle to remember whatever I do to one side, I do to the other. I'm going to choose to multiply both sides by 2. Because 1/2 times 2, that will cancel each other out. So I multiply 48 times 2 is going to give me 96 equals x minus 36. Now to get x on the side by itself, I have to add 36 to both sides. This is going to cancel out. 36 plus 96 is equal to 132 is equal to x. So I can say that the measure of my arc AB is equal to 132 degrees. Okay, let's do another one. Okay, this one is a tangent line and a secant line. So this one says the measure of angle ADC, so this angle right here, is 39. All right, my arc AC, so from here to here is my arc. Whoops. And that is 68. Find the measure of arc AB. So they want me to find this guy right here. Well, we're going to call this X. Okay, so remember that my angle, so in this case 39, is equal to 1/2 times my far away arc, which I don't know, minus my close arc, which is 68. Okay, I'm going to choose to do this the same like I did last time. Actually, I'm going to show you the other way just in case you want to switch it up. I'm going to distribute this 1/2 first. So I get 39 is equal to 1/2 x minus half of 68 is equal to 34. I am then going to add 34 to both sides. So this is going to cancel out. Whoops, sorry. 39 plus 34 is equal to 73. Is equal to 1/2 x. Okay, and to get rid of this 1/2, I'm going to multiply both sides by 2. So 73 times 2 is equal to 146 is equal to x. So I can say that the measure of arc AB is equal to 146 degrees. Okay, next. This one is made up of 2 tangent lines. This one says that the measure of my angle, ACB, is 109. And I want to find the measure of arc ADB. So I want to find this guy here. Okay, so this is what I don't know. Now, this is the part that's tricky. They don't give me this part. But here's what I do know. I know that the x, the measure of arc ADB plus the measure of arc AB is equal to a whole circle. So this purple arc is going to be 360 degrees minus whatever the orange guy is. So let's just think about this logically. Let's just pretend for 1 second that this x is 200. Then I would know that 360 minus 200 would give, would give me 160. 360 minus 200 equals 160. So if you can't come up with a formula right away, it's okay. Plug in some numbers so you can understand how it works. So we know that this is going to be 360 minus x. Okay, so my formula says my angle is equal to 1/2 times my far arc, which is x, minus, now be careful because we're subtracting a group here, minus 360 minus x. Okay. You want to be careful when you subtract a group because you're actually, I'm going to write this a little bit bigger so I can have some more space. Minus 360 minus x, like this. Okay, so when you're subtracting this group, you want to put it in parentheses because you have to add the opposite of everything on the inside. So really this says 109 equals 1/2 times x minus 360 plus x, which is, if we combine our like terms, 2x minus 360. Now my preference when I'm solving these is I like to multiply both sides by 2 so that I don't have to deal with my fraction. So 109 times 2 is 218. These go away. 2x minus 360. I'm going to add 360 to both sides. Gives me 578 equals 2x. And to get x on a side by itself, I'm going to divide both sides by 2. So this cancels out. And I end up with 289 is equal to x. Okay, so this is 289. Now I know it doesn't ask you, but we can say that the measure of ADB is 289. Now you could also find this purple part right here. 360 minus 289 is equal to 71. Some problems might ask you for the other one or for both, so just make sure that you know how to find them both. Okay. Case 2 is when we have our angle inside the circle. So I'll talk about the formula in a second. Inside the circle means I'm going to have two secant lines and they're going to cross. They're not necessarily going to cross in the middle, but they're just going to cross somewhere in the circle. So I like to think of it as wherever my angle is. Okay, so remember we learned about vertical angles. They're across from each other and then x. So I call these vertical arcs. They're across from each other. They're across from my vertical angles. Okay, so when we have an angle inside, we take the sum of the vertical arcs. Sum means add, so we're going to add them together and then multiply by half. So here's our last example. So this one says the measure of arc VW is 40. That's this one. And the measure of arc XY is 66. That's this one. So these are vertical arcs because these ones would be vertical angles. And they want me to find the measure of ZW. So they want me to find this one. Okay, so I'm going to say that my angle, which is x, I'm not sure, is equal to 1/2 times the sum of my vertical arcs, which is 66, plus 40. So 66 plus 40 is 106. I'm going to put my line down the middle. And half of 106 is equal to 53. So x is equal to 53 degrees, or the measure of angle VCW is equal to 53 degrees. Okay, let me know if you have any questions. Just make sure that you remember which formula you're using based on where your angle is. Is it inside the circle? If so, you're going to use the sum of the vertical arcs. If it's outside the circle, then you're going to use 1/2 times the far away arc minus the close arc. Good luck.